mainly we are going to be looking at class A, class B, and class C of IP addresses. Now let me just write an example IP address out again. And you guys remember that each one of these sections is known as an octet. By looking at the first octet, okay, looking at that number tells me what class that IP address belongs to. Whereas a class A, that octet will be a number between 1 and 126. If it's class B, that will be a number between 128 and 191. And if it's a class C address, that number will be between 192 and 223. The numbers 127, which you guys see is missing from here, and the numbers 224 all the way up to 255 sits in class D and class E, used for testing purposes and used for multicasting purposes. So for us as normal network technicians setting up a network, we don't really have to worry about that. Okay, so that's the first thing that we can learn by looking at an IP address. By looking at the first octet, the first number, that can tell us if it's a class A, a class B, or a class C address. And then by looking at class A, B, and C, I can tell you then how big is that network. Does it have a lot of hosts, or does it have a very small amount of hosts? Okay. The second thing that the classes of IP addresses tell us, just making some space here for us, and let's also move my camera again down to the bottom so it's not in the way, okay, is something called the subnet mask. Okay, now what is the subnet mask? I'm going to put it over here on this side. The subnet mask tells us which part of the IP address is for the network and which part is for the host. Okay. So, what are the different subnet masks? For class A, we have a subnet mask of 255.0.0.0. For class B, we have a subnet mask of 255.255.0.0. Okay, that doesn't look like a 5, but it is a 5. And for class C, we have a subnet mask of 255.255.255.0. Now, what does this mean? The 255 tells you that that belongs to the network ID. And the 0 tells you that that belongs to the host ID. Okay, so to put this all into perspective, I have an IP address. Okay, by looking at the first octet, I can tell you that this is a class C IP address because it falls between 191 and 223. Because it's class C, I can tell you that the subnet mask is 255.255.255.0. And by looking at the subnet mask, I can tell you that the first 3 octets is the network ID, and the last octet is the host ID. Okay. Let's take another example. Let's take 168.32.4.8. Again, by looking at the first octet, I can tell you now that that is a class B because it falls between 128 and 191. Because it's class B, I can tell you the subnet mask is 255.255.0.0. Sorry. And because I'm looking at the subnet mask, I can tell you that the first 2 octets will now be given to the network ID, and the last 2 octets is given to the host ID. Okay, so you can get a lot of information from an IP address. By you giving me an IP address, I can tell you exactly what class it is, what part is the network ID, the street address, and what part is the host ID, the house number. This also tells me if I'm designing a network for this IP range, all the computers in that network must all start with 168.32 because they all need to belong to the same network. And then I can say the last 2 octets must be different, must be unique, because they belong to the individual hosts. Okay. So then the last thing that we need to quickly discuss is the difference between public and private IP addresses. Okay. Now, let's say we have LANs, okay, and these LANs are connected onto the internet. Because we just learned that IP addresses identify the unique device that we have. If this network has 100 PCs, and this network, let's say, has got 200, this network's got 50 PCs, and this network's got 10 PCs. To connect all of these computers to the internet, I would need to have 200 plus 100 plus 50 plus 10, so 360 unique IP addresses to connect each PC to the internet. Okay. Now, IP version 4 gives us millions of addresses that we can use. But, of course, there are not millions of devices on the internet. The internet has got billions of devices. Just think of your own house that you live in right now. How many devices do you have in your house that connects to the internet? Most people will have at least 3 cell phones, a laptop, maybe a tablet, maybe the smart TV. You know, in my house, I've got 2 laptops, a desktop. Each one of us got a cell phone, so that's 3 cell phones. Each one of us has a tablet, so that's 3 more tablets. So just in my house, I've got like 13 devices that need to connect to the internet, and we need to have an IP address. And that's just my one little network. Think of a computer, a network that's got 1,000 PCs. They would need 1,000 IP addresses to connect. So if we give every single device a unique IP address so that they can connect to one another, we are running out of IP addresses really quickly. So what the powers that be, specifically the IEEF has done, an organization that standardizes IP addresses, they have said that we are going to do something where if you're running in a LAN, you must use private IP addresses to communicate inside the network. But as soon as you want to communicate outside of the network to something on the other side, then you would need a public IP address. So if I take one of those networks and I zoom in on it, these 3 computers inside will all have a private IP address that makes them unique. And then I'll have a device that will have one public IP address that will allow it to connect to the internet. So now if a device wants to connect to the internet, it doesn't connect straight to the internet. No, it connects to the little device that will convert that private IP address into a public IP address, and then that device will connect to the internet. So all the PCs connects to this device, and you have one connection connecting to the internet. So even if I have 1,000 PCs or 1,000 private addresses, I still only need one public address to connect to the internet. So this is how we've gone around the fact that we are running out of IPv4 addresses. We cannot give every single device its own unique IPv4 address. We're going to have them all have private addresses in the network, but then as soon as they want to connect to a public network, we'll have a device that will give them one public IP address for all of the private addresses, all the devices inside the network. So now, instead of having 1,000 addresses, we only need to assign one address to that company. Okay. And just for interest's sake, this device is known as a NAT. If you ever hear that term, it stands for a network address translation device. It translates a private address into a public address.